log synchronization with Elasticsearch and log data in a distributed environment. That's also a mouthful, just like Walter had with the description from Wikipedia. In essence, what we're talking about today is that as a client, when you have an infrastructure that is distributed or running your whole business, you face several challenges to understand what's going on with your machinery. That can be very diverse in essence, in the sense of what can happen, what is going on, and why is something not working, or just an overview thing where you have, for example, a situation that you need to monitor things. The role of logging in that is that, we are going to look at log files, stuff that you just saw in Walter's presentation, and we're going to look at the right technology to evaluate these log files. And after the boring slides, we're going to have hopefully a nice short visual demonstration of the pure usage that is interesting for the end user with Elastic. So start with the client challenges. What are common client challenges that you have today? Well, first thing is that architectures today are distributed. The cloud is a big word. Everyone uses it. In essence, it means you have different kinds of installations at different locations. You do not have a server room anymore at a client facility where you just have these machines and everything is installed on them. And you have high complexity. That means you have, for example, one application that is run by a client that is not necessarily just on one computer anymore, but it can be split up. Some of the services are on one server running in America. Then you have a database somewhere in Europe, whatever. It is highly complex in the current installed infrastructures of the clients. Also, you have a technology mix, which means you have something like an old technology versus new technology. So things like old mainframes at banks, they are still running a lot of the accounting. And you have new technology like modern Java installations that do web interfacing. All of that is very complex. It needs to be accountable because the infrastructure usually means the lifeblood of the client. So what are logs and why are they important in this context? Usually logs is all what you have. The common denominator is the text output of a log file. So when you have developers and they build an application, what they usually do is they print at some point some debug information into a text file. That can be anything. That can be a current readout of a sensor. That can be a state of a piece of software. That can be a user account that logged on. It is not really defined what it is, but usually you have some sort of text log of what is happening. It is very different content-wise per entry. Like, for example, the entries of a Java application do not necessarily look like the entries that you get from a log from a Linux machine with some kernel issues, or maybe like a mainframe that prints something out. Also, you have high frequency through multi-user scenarios because everything is networked, everything is used by multiple people at the same time. You get immense volumes of this stuff in the log files. So that means it's chaos for anyone who has to interpret anything from log files. But you still need to understand everything that's going on because that is the only thing that tells you if your infrastructure is okay or not. So how do we understand log data today? If we have, for example, an incident, let's say you have an installation at a big client and they run their financial databases on there. Someone says, okay, there's an incident, something doesn't run, so a technician goes there and starts to inspect the logs. First problem that he has is there is no central log file. So he has to go into server 1, look at a couple of log files, then maybe go to server 2 with the database, look at a couple of log files. There is no central repository. Also could be that perhaps if you have something like Kubernetes that in essence clones services, that you get a fragmented list in the log file. Like, for example, a user starts something on a website and it prints something in one log file, but then he uses another instance on Kubernetes and that prints into another log file. So you have fragmentation problems. And you need a lot of work to piece these infos together, especially when you have to do it in a real-time scenario. So if it says like, we need to react on this in 1 hour, then you're really under time pressure to get this. So it's high cost with the operational time is a big issue for the clients usually. But even if you find all the logs, that doesn't mean that you're already golden, because the log content itself can be extremely complex. You can have timing events that maybe happen in a specific order or in an order that changes. You can have varying sequences, something like a thing that prints out 1, 2, 3, 4, but in the next time it only prints out 1, 2, 5. And something in the middle didn't really work, or you have incomplete or duplicate output that maybe you have duplicate lines with just different timestamps, you have inconsistent output, lots of problems with the data in the logs itself. So we need a better way to access all that and to organize it. And we need a sort of centralization for the data. That, of course, then brings a lot of problems in the sense that there are many, many files on many machines that need to be watched. So you have, I don't know, 1,000 log files that all contain something interesting, but you need them all in this central place that you can actually then go ahead and evaluate them. It also needs to be manipulatable, so you are able to understand what it is, what you're looking at, to filter it. And you have the big problem that big data, the thing that is usually the common case in big infrastructures, the data sets are enormous that are being generated. You can have log files with gigabytes and gigabytes and gigabytes just on one machine. If you then have to wait through all that, you need a lot of time or a lot of ability to really pack that together. So maybe we'll just all put it in a relational database, but that will not really be that easy. Relational databases, something established like MySQL, Oracle, PostgreSQL, they all have very strict ingestion rules. So you cannot really go ahead and just put any kind of data in there. You have to adhere to a schema, an ability for the data to be structured and organized, that it fits onto the layout of the database. It needs normalization, so you have to deduplicate it if you have duplicated output, or if you, for example, have the name of a person in a log file, and then you have the name of a person in another log file, and it's the same information, but has sort of different pieces. You need to only save the name once, and the normalization usually takes a lot of thought what you have to combine. And then also, the log data can be wildly different, as said before, between the different outputs of the software. So you could, for example, have application A that does something like print out incoming payload and some numbers and an OK. And then you have application B that just prints out some name of the Java file with some line number and ingestion blocked and a thread number. The only thing that is really consistent in these both log lines is that they both have some sort of timestamp in the beginning, and even these timestamps differ. So while you put it in a relational database, you would have to create scripts and cut the data in many ways, a lot of manual work that creates an immense engineering backlog. So relational database, probably not the right tool for this. Okay, we need something more modern. And that is, in essence, where the thing that I want to present today comes in. That's called the elastic ecosystem. It's sometimes abbreviated to ELK, which means Elastic and KIBANA. KIBANA is a tool that comes with Elastic for visualization. It is a search solution that allows for immense flexibility in faceted search, in sifting through immense amounts of data. It is designed for big data, so it can be used with immense volumes without any hiccups. That is also a problem with relational databases. Also, it's standalone and distributed, so you can cluster it. You have the ability to create network meshes of Elasticsearch systems. And it comes with a lot of utilities to allow for accessing data, for spooling data into Elastic. Let's start with the heart of the thing. It's called the Elasticsearch service. That is, in essence, the pure data handler that really picks up all the data and really saves it in a way that it can reuse all the information and that it can be queried. So it's enterprise open source, which makes it very attractive for companies like Capgemini with big customers like the official defense people, government things that are being set up, etc. Everything that needs a very good support, where you can actually say, hey, I have an issue, I need someone really experienced to look on that. And you can have, with enterprise open source, you can have partnerships with Elastic to really get source knowledge in there. Elastic in itself is schema-free and document-based. That is sort of like a different approach to the relational databases, in the sense of that it uses single documents to save data and organizes them in sort of filing cabinets. It also has a NoSQL approach, so it's not using the typical SQL normalization to query all the data. And everything you can put in it can be encoded, for example, in JSON, which makes it already very friendly towards all the internet developments. Let's look at the sub points a bit more in detail. It's a distributed system. That is necessary because if you have very large volumes of data, the typical big data problem, you have a volume that you still need to be able to sift through. And that means you have more than one machine that actually keeps all these things online. Elasticsearch can do that. It is easily clusterable and also has cluster replication. That means you spool something in somewhere in the cluster, and it automatically works that it actually tries to make this data available in the whole cluster and actually replicates it reliably. The same if you kill something in the cluster, it automatically distributes all this. All the hard things like the network communication, that's all solved in Elasticsearch. You can just set it up. You can set up shards, which are sort of like duplicates of the storage functionality. And it, of course, has very complex security possibilities, something that you just need when you want to have something in a big enterprise environment. It's built for the modern web. So it works with REST APIs, with UTF-8-based JSON. So you are able to easily connect to it via HTTP. And it is language and environment agnostic for the REST API, because as long as you can open a port in your language, you can talk to Elasticsearch. That's also why it is very easy to just use it in Python, in C++, or whatever, because all these languages have basic network connectivity, and that is completely enough to talk to the system. Now, where it shines are the search and indexing capabilities. Has a lot of acceleration structures, very technical things like KD trees, reverse indexes, etc. So that means even if you have a lot of data in it and you type, it is nearly instantaneous when you get information out of there. So you can query specific properties, but it still reacts almost in real time. And as soon as you spool in new data, it is immediately indexed and immediately ready to be searched. So there is no waiting time or crunching time. It has machine learning features that can automatically detect things like aberrations in your data, sort of like unstructured changes that are out of the statistical norm. It is it is very easily queryable, even with complex queries through a JSON-style query language, and it even has cross-index searches. That makes it, in a sense, like a Google for your organization. You can just set up an Elasticsearch server, and that is sort of like you've just created your own little Google for your data. Now, how do we get things into Elastic? That is the main problem that you have with all the technology that involves data. A database is only as good as the data that is in there. And here it shines as well. It brings many utilities directly with it that you can just set up on, for example, a Linux system. There's certain beats utilities which can be used to ship data, so-called data shippers, into Elastic, and they allow you for just a couple of config files setup, and then they spool all the live data that constantly happens in these logs directly into Elastic. And then on the presentation side, we have KIBANA, which is a very visual medium to check these data parts and to really look through it. Now, the beats utilities are the data shippers. That is a set of helper utilities that come immediately with the Elasticsearch service. And they are really able to monitor practically anything. You can monitor packets that are going through the network. You can monitor files that you want to watch, in a sense, whatever you want. You can pipeline it. It has lots and lots of abilities to script these watchings, so you can actually transform the data before you pack them into Elastic. So many utilities that are helpful. And then you have KIBANA, and that is the front-end part of the Elasticsearch service, where you can do queries and visualizations. You can build metrics, and it is actually able to build dashboards. And that is what actually is the kicker for the regular user that doesn't want to go in depth into the data. You can set up through the quick reaction time of Elasticsearch in combination with KIBANA, can set up real-time dashboards that, as the data changes, react as quick as you would put something in Google, but with graphs and everything, and with the appropriate security, just ready for the end user to really use it. So you could say Elasticsearch is a utility that allows you for a lot of live insights into any system, no matter how complex it is. You can have multiple servers, you can have tons and tons of log files, you can have lots of different situations where something is emitted somewhere in a log, and you can centralize it all, searchable, faceted into an Elasticsearch server that allows just very quick reaction times to problems that you need to look up. So with saying all this, I think it's also demo time. So I would just close my presentation and then, in essence, look at a bit of data that I have. Of course, log files can be complex, as you've already seen with the log files in the presentation of Walter. So to make this understandable, in a sense, I built a very simple log file that has just a little bit of data to allow for a better understanding of what we're looking at. So I wrote a tiny generator script in Python that does nothing else but create a time-stamped log entry with a value. And that value changes over time. That could, for example, be the log file of a measuring sensor or something that just sits on some machine and just pumps, just with a timestamp and one value of its sensor output, something into a log file. Now, as you can see, that is really not very understandable. But once we have it in Elasticsearch, it becomes really interesting. So this is KIBANA. This is in essence the web console that you can use to talk to Elasticsearch in a very usable way. And it has various tools here in the site with which you can actually create visualizations and also explore your data. The first tool that we are going to look at is Discover. And Discover allows us now to look into an index that we have. We have various indexes here in the Elasticsearch server, and the demo data that I prepared that sits in demo. Now I can do already quite a lot here. I can, for example, do sub-searches on this. I can do certain time frame settings, like for example, I want to see the last 1 year, and I have a timeline here. I have a certain set of entries, and I have 3,000 log entries just from this tiny bit of demo data that I set up. Now, we don't need to look at all of them, but they all look essentially from structure-wise the same. But if I just open up one of them, then we can see what the payload, in essence, of that log file generated in Elasticsearch. We have a timestamp that came from the log file, and we have a value that, in essence, could be, for example, a measuring from a sensor. Now you say, okay, that's nice, but now I can count the values, but that is not really what is interesting. I can here zoom in here in the time, and as soon as I start to get closer, I also see that they start to split open, and that is already something that Elasticsearch does for us. If we, for example, give it a time frame, then in essence, it allows us to aggregate automatically how these things split into each other. So, for example, I have 16 or 13 in this case entries that go into 1726 in this time range. And I can zoom in however I want. Now, this raw data, of course, is interesting, but we would like to have a better understanding what happens here with the sensor data. And of course, just discovering it is not really a big benefit. So what we're going to do is now we're going to build a visualization of what is really going on in this data. And for that, I'm going to use the visualize section in KIBANA. Well, there are already a couple of visualizations in here, but we're going to create a visualization from scratch. And we're going to do that as a line visualization. There are certainly a different amount of visualizations that all have specific purposes, but for now we're going to stick with the line. And then it asks me what kind of data I want to query, and I'm just going to use the demo data from the index. Now, as soon as I do that, I get sort of a compose view where I can create a visualization of this data now. Just to see all of the data, I can already do that here in the compose view. I can just go to all the data of the last year, which is in essence a year ago up to now. And I see there are those 3,000 points, but I can't really zoom into them because the visualization just shows that we have these docs. So the first thing we do is we want a timeline down here to be able to really manipulate this data. So I'm going to bucket it, and I'm going to do this on the x-axis, which is this axis here. And then I'm going to say I would like a date histogram. A histogram is in essence just a counter for a certain interval of all the things that we have. And once I do apply changes, I now get timestamps down here. And already here, I can zoom in again. And KIBANA allows me automatically to go to the right set of data. I have to zoom in a couple of times. And then it automatically aggregates over this time frame what I see here. Like if I zoom in now, I suddenly get now a lot of different counts of these entries. But counting the entries is not really what interests me. What I want to see is what happens with the value that we have in these log entries, because here I have 6 entries here, but what I really want to know is what is the value of these 6 entries. So I'm going to do the metric on the y-axis, and I'm going to say, give me the average of one of the fields that you have that is able to be evaluated like that. And since the value field is a number field, I can just use it here for the average. And if I press start, then that is actually the average of the value and not the count of the entries that I have here. So I could say, for example, the average value in this area here was 9.642. And that is once again aggregated. If we have multiple values in this area, then it will calculate the average automatically. So if I just zoom in this area, I see that there are actually many entries. And all of those are already going into the average and being on the fly calculated by this system. Well, let's go back one level. And now I say, okay, but the average is nice, but what was the min and the max? And I can just add those equally to the aggregation. So I can, for example, say I want a min value, select a field that actually allows for that. We're going to say the value field. And I'm going to add the maximum. It's all very clicky, so not really something that you need to code. And now I have the minimum and the maximum. If I now click apply changes, I have multiple curves that are in essence displaying the data of the aggregation that I have on this time slot. So if I look closely at those here, I actually see that, for example, here there was fewer entries, so the aggregation landed for all the 3 curves on one point. And at this timestamp, I have multiple entries, and they range from 10.9 to 11.56 about, and the average is somewhere in the middle. So I can also change colors. Let's change this to yellow, to just sort of yellowish, orangey, to make it a bit better viewable. And the average, let's make that one black. So, and now I can just go ahead and say I'm going to save that, and I'm going to call that demo visualization 1. And I can say a description, so min, max, average of sensor data. And I do a save. So I can also now go ahead and, for example, say I want to, for example, only have a certain amount of these entries, like everything over 10, for example. Then I can just say value larger equals 10, update it, and it will filter out all the relevant lines and still do the auto aggregation that we have in here to allow me to see all these systems. So update. I'm going to do a quick second visualization, and in this case we're just going to do a count metric, which is nothing more than a number. And this number, for example, could be that we have a problem with the sensor, that it is maybe too cold in a sense in the environment that the sensor is actually reading. So for this case, I'm going to say value larger equals 10. And then I'm going to get a count of how many entries I have that are larger 10. Or in this case, maybe let's make it an underrun. let's say we're gonna say how many we have below 10, and that is then 22. And let's save that, for example, as demo visualization 2. So we have a bunch of metrics that we can use to do something. And now the main kicker of the thing is that we can combine these metrics into so-called dashboards. So I'm going to create a dashboard that allows me to combine metrics that I have created. And I can just add these metrics just by clicking them and adding them to the dashboard. And now I can say save and say demo visualization dashboard. This dashboard shows the current sensor states. Of course, I can then, for example, go ahead and edit these things so I can name this in some more useful manner. Like, for example, I can say, let's call this sensor underrun, and let's call this here sensor timeline. And then we say save. And now these visualizations update automatically if I just change the time frames. And this is something that you can give an end user, in essence, to monitor its entire system. So if I, for example, say I want to look into these things here, the data points that I have, and the further I zoom in, the more it aggregates. So let's say we're going to look at these parts here. And then we can actually see what the sensor is doing. It's actually going down to a certain level, going up again, having an oscillation, and in essence, a bit of noise with the min-max values that I can actually see. And I can see, for example, 10 is our cutoff. So we have 527 sensor underruns. So you can build dashboards with this from log data that are very, very complex. Of course, I cannot do a simple demonstration of the full capacity of the system in the short time that we have. But I'm just going to show you two quick demo dashboards that you can get with KIBANA, in the sense of to show you what the capabilities of these things here are, of these visualizations. And the first one is called the e-commerce dashboard. As you can see, you have a lot of different abilities to really get some things out of the log data, like automatic calculations. You can have certain distributions. You can have map views that actually zoom in and auto aggregate. If you want to, for example, look at what revenue in for example, England was produced by the system, and it automatically aggregates all the subsections. And the further you zoom in, the more data you get. You can actually look at the total quantity of things sold. You can look into details. So lots of possibilities. And of course, you can also query all of this, like I just did with the underrun of the sensor. Could say you want only to see a manufacturer like this, and automatically the whole dashboard will then, will in essence update to only give you the numbers of this guy. And my machine is a little bit slow. Usually you have something like these services run on a big server, and you have immediate insight into what's going on in an end user way. Same thing with, for example, web traffic. If you, for example, have your web servers that are spewing data into your log files, you can then say, I want to have visualizations on which countries these things come from, which country they come from, and which country they go to. I can see what the different states in America, for example, get out of this. And I can zoom in, and it automatically splits open to the right aggregation. So it is a very, very powerful tool with the ability to do lots and lots of things. So you can, in essence, allow for this system to evaluate everything in a real-time manner that you can think of. Yeah, I think that's sort of the demonstration time. Thanks so far. So do we have any questions?
Thank you, Marcus. Looks really well. We got one question, and the question is, in a chain of systems, incidents can occur due to a fatal combination of events occurring in the chain. Is it possible to perform intelligent log analysis in a complex chain to find these combinations?
Yes, that would, for example, be the case if you know what sort of log entries you're looking for. Of course, this has to be investigated for once, but once you know what to look for, you can definitely automate that in a dashboard, and then, for example, tell Elasticsearch to automatically generate new entries that you can evaluate in the dashboard as an alarm, for example. Or you look at different time series, and then you maybe have different entries in that sense. As long as you know what to look for, or as long as you are able to specify what you want to display in these dashboards, then you can practically infer anything. You just need to dive into the data once and see what the system produced, and then you can isolate that and let the system warn you that anything like that happens. So definitely possible. We're also doing that for customers. When you have, for example, when you have delivery systems that have digital signings that they constantly spool between the systems, then you can, for example, look for error messages in the certificate systems, and then can pop that up as an error message that is that, for example, 5 error messages happened in the last 3 hours. No matter what sort of visualization you want, you can definitely find a tool in KIBANA to allow for these numbers to be spit out. So that is really, really useful for people that have to maintain these systems and keep them running, because those are all black boxes. If you don't look into the log files constantly or know what to look out for, that's just cloud computers running.
Okay, that's a very good answer. Yeah. So it's not only possible, but also really happening.
Yeah, exactly. Already. Yeah. I see we got another question.
Yeah, we got another question in the comments.
Yeah.
The question is, I've worked at a customer where all the applications produce their own log files, each in their own format. Is it possible to easily switch an existing application landscape to the ELK stack?
Yes, it is, and it is actually not a switching to something, but it is more a system that goes on top of the existing architecture. So you never really delete the log files of the machines, or you touch them, or all the applications need to be able to save something in Elastic. That is what the beats utilities are for. No matter how your log file looks, you can just get a beat utility and can spool that log file into a beat utility. And if it needs to be snipped up or transformed in a sort of sense, that can be programmed in there via short scripts that do all that automatically while stuff goes into the log file. So as soon as something new is added to the log file, the beats utilities picks it up and spools it to the Elastic server. So you don't need to replace anything in your application, no matter how the files look. You can just put an Elastic server next to it or somewhere else in the cloud, and then you have beats utilities that just spool to this Elastic server. They watch all your files, no matter how different they are from the format. You just have to figure out how to cut them up once, and then you can just automatically get them spooled into the Elastic system.
Okay, that's good to know. So it's not only applicable to greenfield projects, but also to legacy projects?
Yeah, of course. It is especially useful with legacy when there's like tons and tons of old stuff that no one really knows anymore, and the service just spits something into the logs. That is really the real-time aspect of this tool is what makes it so immensely usable. You can just type something and it runs for terabytes of data and just gives you answers. That is tremendous.